Hi, my name is Roland, and for today we are here at the Powerwall, and I want to speak about a topic which is looks like the most interesting for the viewers of this kind of DIY battery builds, and it's about BMS and balancing. So here's my battery pack. You know, it's 48 cells, lithium iron phosphate cells, and they are connected into a 16S 3P battery pack. So all connected via bus bars. And for those who have looked my series, they know I'm just using a very simple 16S BMS. And this is how the pack is configured. So what about the BMS? Every one of you who is interested in lithium ion cells knows that it is very important to have a BMS battery management system. Every BMS typically has two parts in it. One is over and under voltage protection, and the second part would be balancing. But the balancing inside of BMS is this part may vary very much, right? So this doesn't matter if you have a cheap or expensive BMS. The voltage protection will always work the same. The more expensive ones, maybe they might be programmable. You can change voltages or whatever you want. With the cheap ones, they are set as they are in the factory. But that feature is of course extremely important, because you don't want that a faulty cell is running away out of the limit over voltage or under voltage. For the balancing part, every BMS, the balancing is just kind of a basic feature, and in almost every case balancing is done by switching on resistors on the BMS, inside the BMS, to burn off some extra energy if one cell is kind of passing over the threshold which is set. There is then extra active balancers which could then provide a little bit better service, because I will just show you in a second why this kind of BMS actually does not balance at all, or why I consider it a non-balanced system actually. So this the balance sheet of this cheap BMS will tell you that balancing is done by switching on resistors and causing burn of energy with 30 milliamps, right? So 30 milliamps, this is a 300 amp hour battery pack. We have two chargers, and they are now putting out 45 amps, right? So if this BMS would now start balancing because of over voltage condition on one cell, it would still have to work against two chargers putting out 45 amps. So this is basically nothing, not even a drop in the ocean, right? So balancing is something what is absolutely not done here, right? But is this actually something bad? I have to tell you that when I bought these cells, I have basically measured all the voltages, and I separated the cells by voltage, and thereafter I took the cell with the highest voltage and connected them in parallel with the cells with the lowest voltage. So I equalized all the cells, and at the end, after a few days, I had 48 cells ready to be used, and they have been sitting all about in the same voltage like the other ones. And then I have put them together and again paralleled a little bit cells with a little bit lower voltage together with higher voltage, etc. So when I put this pack together and tested the first time, I saw which this 16 cell group was first low on discharge and first high on charge. So it's always this one which is first down and this one which is first up, and it never changed, right? I'm using this pack already for 4 months now, charging, discharging, and it's still always the same. And the cells, they never went out of balance. And the one reason for that is also the chemistry and how you use these prismatic cells. So lithium iron phosphate cells, if you use it with really low C rates, in my case I'm using them maximum maybe 0.2 C, they're always same, you know. These are used cells, so there could be weaker cells in here, but they don't show. They really don't show. They're all same, but the pack was probably also before was together in a system, so they're all degraded the same way, and it's absolutely no question about balancing here in this case. If you balance something what appears not to be needed to be balanced, you know, we DIY makers, when we build things like this, we know it, these systems like it would be our babies. And if you operate something and there's no obvious problem with your system, there's no need to touch it with some extra electronics. But a much more important tool than a balancer probably is a simple multimeter like that. And if you check it up once a month on your cells, it will be perfectly okay. Of course, if your battery pack is built out of different kind of cells, like the 18650, something like this, where all the cells are very different, and you know, the use case scenario was completely unknown, and then maybe one cell came out of a tool and the other one came out of a laptop, and nobody knows how many cycles. In this case it might be good to use balancers, but you have to be careful. The balancer can of course hide some problems with the packs, right? Without a balancer you will see how much and how fast cell groups will run away from each other, but if you connect a balancer, this can of course hide all those things. And of course expensive balancers would then have the chance maybe to have the option to look into some log, and you can see how much energy was transferred, and if the amount of energy is extremely high, then you can tell, okay, this cell group is really bad. But yeah, so BMS, low voltage, high voltage protection is an absolute must on any lithium ion chemistry. And the other things on my Powerwall, for example, there are several layers of protection here. So first of all, the controller is taking off on daily operation, also checking for the limits and stay inside the limits, of course. But the controller doesn't know about the individual cells, so it only measures the total voltage of the pack. Same is the inverter. The inverter will also cut out at the set low voltage level, and the rest is BMS by itself. So it's very unlikely that something goes that far out of control that none of these three layers of safety will kick in, right? So BMS, very important, balancing in my case, I would say here, until I don't realize that there is something going wrong, you know. If I see one day that a completely different string of this pack is starting to behave differently, which was not before like this, starting to run away low or high, then there's absolutely no need for me to look for balancing. But that's what I want to say about this. And it's of course everybody's decision how much money he wants to spend, how much of electronics he wants to then add to his project. So thank you for watching this episode, and please check on my playlist for other videos, and I see you next time. Thank you.